Hello, my name is Wyatt Harvey. This is my ME 272 Mechanics and Materials presentation on the aerodynamic forces on an IndyCar main plane. Some of the background, the application that an IndyCar main plane is used in is to support the front wing end plates and end fences of an IndyCar on the racetrack. They're very important because they're a critical component to keep aerodynamic performance up and channel the airflow around the car to help suck it down to the ground and also to reduce the drag that the car has. The problem definition, the object that we're going to be analyzing is the front wing main plane. And some of the loads that will be applied are mechanical forces like the aerodynamic force as well as the force of downforce. There can also be certain things like drag, but we will ignore it for this example. Some of the design criteria and constraints involved with the front wing main plane criteria would include maximum deflection from horizontal, the maximum allowable force, the weight of the main plane, as well as the stiffness and durability, so that way it can last through a couple of races. Some of the constraints of this are the size and shape of it, where its location is physically on the car, as well as some of the materials that are outlawed by the rule set that the organizational body of IndyCar sets. So far, this is the example problem that I begin to work out. The idea is that you'll be solving for maximum allowable deflection and the maximum allowable force and checking the tolerances of it. So an IndyCar front wing main plane is designed to create downforce levels of around 1,500 newtons at 200 miles an hour at the famed Indianapolis Motor Speedway. The main plane is made of carbon fiber with given dimensions of 177.80 centimeters wide and 5.8 centimeters thick. Is attached to the chassis using struts and braces. IndyCar regulations state that this main plane cannot exceed a maximum allowable strain of 0.5% and cannot deform more than 0.1 centimeters. Using the information provided, we have to determine the maximum allowable force and the maximum allowable deflection for this design and verify it is within the rule set's allowable tolerances for strain and deflection. Here's the free body diagram of the model so far. As you can see here, this is where the main plane is. It gets attached to the chassis right here in this little notch using those struts and braces, and the end fences sit right here. So there's the total length of the main plane, also the given thickness given for all the way through. Force of downforce has been abbreviated as FDF, as well as showing all the forces applied horizontally down onto it. And then from Appendix F, I began to look at this formula to determine what I needed to use for it and for this model, which I discovered it would be the FDF L to the fourth over the 8 EI. And so I will begin to look into some of the Young's modulus and other information needed to solve for this problem. Thank you.